Hi guys, every day is a new opportunity to achieve your dreams, including this day. You can read this question for a while. We have a curved board on a smooth flat surface. On the curved board there is a small ball. The ball then moves to the right with an initial velocity of v. Since the surface of the board is curved, every time the ball will hit the board, the ball pushes the board forward. The board also moves straight to the right through the smooth floor surface. The ball eventually leaves the board after reaching point P. The ball will perform a parabolic motion. Since the floor is smooth, the wooden board will move with a constant horizontal velocity, even though the ball is no longer pushing it to the right. Something interesting about this question is that the ball will return to touch point P once again. This requires a special criterion. We are asked to determine the mass of the board, so that the ball can land on the same point. This seems simple. Is it really so? Let's think about it. Okay, this is a simple illustration of the question. Before doing physics analysis, we must be able to identify what quantities are important. Let's say the mass of the ball is m. The mass of the wooden board is big M. The initial velocity of the ball is v. The angle of elevation from point P to the flat surface is alpha. The values of m, v, and alpha are definite and fixed. The only quantity whose value is uncertain is big M. We will express this big M quantity as a function of the known quantities. Functions of m, v, and alpha. This is the initial condition. Let's say the ball leaves the board here. At point P, the velocity of the ball is v1. At the same time, the velocity of the wooden board has reached v2. Note, the directions of v1 and v2 are different. These two quantities cannot be added directly. Therefore, we will resolve the velocity v1 into a vertical component and a horizontal component. v1 cosine alpha, and v1 sine alpha. We have two conditions. Conditions when the ball first moves, and conditions when the ball leaves the surface of the board. Let's call these conditions as conditions 1 and condition 2. In condition 1, the board is still not moving. In condition 2, the board has reached a speed of v2. What can we think of from these two conditions? That's right. The ball hits the wooden board. This is a collision event. Because all surfaces are smooth, there is no external force here, so the law of conservation of linear momentum applies. Initial momentum is the same as final momentum. Momentum is a vector quantity. Because the wooden board moves straight to the right, we will analyze the law of conservation of momentum for the horizontal direction only. The initial momentum of the ball is mv. The initial momentum of the wooden board is 0. The final momentum of the ball is mv1 cosine alpha. The final momentum of the board is big M v2. Let's call this equation 1. Next, pay attention to this short animation. One of the conditions for the ball to land at the same point is that the horizontal speed of the ball must be the same as the horizontal speed of the board. If not, then the ball does not reach point P exactly. This is condition 3. From condition 2 to condition 3, the horizontal speed of the ball and the board are the same. We can write v1 cosine alpha equals v2. This is equation 2. Look at the two equations. There are three quantities whose values are unknown: v1, v2, and big M. Even though we only have two equations, we cannot solve two equations with three unknown variables. We need one more equation. This one equation can be obtained from the law of conservation of kinetic energy. We will evaluate the kinetic energy between conditions 1 and 2. Half mv squared is equal to half mv1 squared, plus half big mv2 squared. This half number is quite disturbing in the calculation process. We can cross out that value. Finally, we have three equations with three unknown quantities. Up to this point, we only need math skills. Let's clear this screen. Substitute v2 from equation 2 into equations 1 and 3. In equation 1, the right-hand side contains v1 cosine alpha. You can simplify the value on the right side. V in equation 3 is a square. So, square both sides of equation 1. Observe these two equations carefully. To make the two equations similar, multiply equation 3 by m. Both equations contain m squared v squared. These two values are the same. Next, describe the values in squares. This equation contains the quantities m and v1. Just divide all the factors by m squared v1 squared. There is a cosine squared and 1. An idea comes to mind. That's right, we can write this equation like this. Because 1 minus cosine squared alpha is sine squared alpha. We see cosine and sine there. That's right, just divide sine by cosine. Because sine over cosine is tangent. This equation only contains one unknown quantity, big M. I think it only takes a small step to get the answer. Let's just think of big M over M as lambda. Lambda squared plus lambda minus tangent alpha squared equals 0. We can use this formula. Since mass is always positive, just take the positive value. Now we can write lambda as big M over M. Big M is equal to half m times the square root of 1 plus 4 tangent squared alpha, minus 1. This is the mass of the board so that the ball can launch and land on the same point. I hope you found something useful in this video. Don't forget to watch the next video.